Today's lesson is about using postulates involving points, lines, and planes. We've already talked about these pieces, these geometrical figures, but today we're going to apply them to some postulates and see how we can use them in different types of problems. The first one we haven't really talked a lot about is a line perpendicular to a plane. Here's a picture of what it looks like. We have a little plane and then a line going through it. So it's going to look like this. It's going to go through it right there. A hidden line, meaning it's going behind it and then out the bottom. Now, is it perpendicular to the plane right now? No, it's not. It's missing something. It's missing something dealing with perpendicular. So it needs the perpendicular symbol. Draw that real quick so you can have something that matches this picture. Really, I'd be happy if you could understand this picture for your definition. The key things you need to be aware of is it's perpendicular all around the top of the plane and on the bottom of the plane, which we can't see. So it's perpendicular on the top where it comes out of and the bottom where it comes out of that plane. The next things we got to discuss are these postulates. So pay attention to these key fill-in-the-blank terms. Through any 2 points, there exists exactly one line. And we've talked about this already. Remember we talked about if you have 2 points, then you can draw a line through those 2 points. So this can be your conditional statement. If you have 2 points, then you can draw a line through those 2 points. That'd be a good picture to have. On postulate 6, it says a line contains at least 2 points. Yeah, we just talked about that. It's kind of the converse, switching the order. The key thing you should realize is it kind of goes in a different order. It says a line first. A line, if you have a line, then you have at least 2 points. So there's your little conditional, your if-then statement using pictures. Number 7 says if 2 lines intersect, then their intersection is exactly 1 point. 1 point. So once again, I draw 2 lines that intersect, and when they intersect at 1 point. So I'm just going to draw a bold point on their intersection. When 2 lines intersect, they intersect at 1 point. Postulate 8. Through any 3 blank points, there exists exactly one plane. Yes, good job. Non-collinear. Who can tell me what non-collinear means? Not on the same line. Points not on the same line. If you remember, I held my 3 fingers up like it hold up a table kind of. They got to spread them out. So you got to spread out those points to make a plane. Here's what it should look like. 3 points spread out. If you have 3 points spread out, then you can have a plane with those 3 points on them. You can make a plane. So there's your little if-then statement with pictures. The next postulate is postulate number 9. It says a plane contains at least 3 non-collinear points. If you are not drawing the pictures out to the side, you're probably going to have trouble today, especially on your homework. So once again, a plane contains. So what should I draw first? A plane. So if we have a plane, then how many points are on that plane? At least 3. So then we can have 3. It has at least 3 points on it. If we have a plane, then there are at least 3 points on it. Postulate number 10. If 2 points lie in a plane, then the line containing them lies in the plane. Lies in the plane. So, what should I draw first on postulate 10? 2 points on a plane, in a plane. So I'm just going to draw a plane with 2 points on it. Then the line containing them lies in the plane. Yeah, exactly what you said. So I draw another plane with those 2 points and a line going through them. That would be a good if-then set of pictures. The last one is postulate number 11. It says, if 2 planes intersect, then there, help me out, Intersection is a line. And this one is definitely harder to draw. Which word is the blank? Line. Okay, so that was our blank. So if two planes intersect, so you got to envision one plane intersecting with another plane. How do I want to do this? And that's not very good, but we're going to move on. Their intersection is a line. You remember me holding up two little sheets of purple paper? When they hit each other, they intersect at a line. So make sure you get that image in your head. Sorry, I'm not taking my time on the picture, but you should kind of have this visualized now. You can look at this figure that I'm holding up. Right there is the line that they intersect on. On example number 1, it says, state the postulate illustrated by the diagram. So we kind of drew these postulates earlier. This one says, if we have 3 points, then we have 3 points on a plane. Which postulate number states that? 8. So postulate number 8. It said, through any 3 non-collinear, there exists exactly one plane. That's not bad. That's not bad at all. Let's look at the next one. On example 2, it says, use the diagram to write examples of postulate 9 and 10. It tells you what postulates to look at on your front page. So number 9, it says, what? What does postulate number 9 say? A plane contains at least 3 non-collinear points. So give me 3 non-collinear points on plane something. Pick a plane. I see V, I see W, and X is not on it. Okay, so V, Y, and W are all touching the gray plane. That is key. So V, W, and Y are 3 non-collinear points. That means they're not in a straight line. What plane contains those 3 points? Q. Plane Q has those 3 points. Make sure to use capital letters because that's how they're indicated in the picture. Postulate 11 says the intersection of plane P and plane Q is line B. And here's how you can check. Look at the edge of this plane. It crosses the edge of this plane. Put a little dot there. Here's the other edge going on the left and the other edge. Right through there is the name of that line. What line is that? Line B, right here. Good job. Try the checkpoints now. See what you can do. Read them carefully. On checkpoint number 1, it says, which postulate allows you to say that the intersection of line A and line B is a point? So I heard a lot of you say postulate number 7. I don't want you to just write postulate number 7. I want you to actually say what postulate 7 is. So what does that postulate say? 2 lines intersect at exactly at one point, at one point. Let's see if it matches. Did anybody say anything different? Which lines allow you to say the intersection of line A and line B is a point? It's perfect. Yeah, so you shouldn't have anything different. It's exactly what the postulate says. Number 2 says write examples of postulates 5 and 7. That means it wants you to use that picture in example 2, and it says that right here. Picture in example 2 for postulates 5 and 7. First off, what does postulate 5 say? It says through any 2 points there exists exactly one line. So in this picture up here, are there 2 points on a line somewhere? Where? Y and X. There are 2 points on one line. So that's what you should use down here. Example of postulate 5. Does it start with the points or the line? starts with a point. So points X and Y. What should I say after that? What's it say in the postulate? Exist on one line? Okay. And I would name the line. Line what? Line A. Line A. Those points, X and Y, exist, or lie on would probably be a better one. So maybe put lie on, lie A. Postulate number 6 says a line contains at least 2 points. It's kind of the reverse of this. So you'd say line A contains what? Points, what and what? Yeah, points X and Y. And that would be a good response there. In this next little concept summary box, it goes over some topics from previous previous sections as well. So all points shown are what? Coplanar. They're on the same plane. The next one says angle AHB, and you can highlight it if need to. AHB is right there. Angle AHB and something else are a linear pair. What's another angle that's a linear pair with that angle right there? I heard BHD. That would work. Angle BHD. There's another possible one that I like a little bit better. How would you name that one? AHF is one I kind of like a little bit better because it's right beside it. It's a linear pair. They make a straight line. AHF and something else are vertical angles. Here's AHF. Which one is vertical to that? BHD. Good. Once again, vertical angles are directly across from each other. They are the same size. If you remember carefully, you could write the letters VA. They spell VA. You just got to turn your head sometimes. The next one. A, H, J, and D are what? Collinear. Good response. They're on the same line. Next one. AD and BF intersect where? AD, BF intersect at point H. Here's some things that you can't assume. I'm not really going to go over all of them. But the key things that I see commonly missed, people assume that we have some right angles in here, but we don't. Since there's no perpendicular mark, right angle mark, you can't assume they're perpendicular. It's also hard to assume if these are parallel or if they're going to intersect over here. It's hard to tell that, so we can't really assume it. There, that's good stuff. Let's move on to the next. In this next example, it kind of gives you the answer, so just focus here. It says sketch a diagram showing, how do you read this? Segment RS perpendicular to what? Line TV intersecting at X. Okay, so do it step by step. First, draw segment RS. So I'll show you step by step how to do it. I advise writing out to the side. Segment RS, some people draw it like that. That's not a very good segment. It should have endpoints. And you label those endpoints with the letters given, R, S. It's perpendicular to TV, line TV. So I need another line going through here. And I can label it TV. And where do they cross each other? Where do they intersect? At point X. Sometimes they do put a point there and sometimes they don't. Since they explicitly said point X, I went ahead and drew the dot on the intersection. That would be a good response. Now there's something that I'm missing. Who can see it? Yeah, that's an important word right there. If they're perpendicular, you need a right angle box. Now it's good to go. Good job. In example 4, it says, which of the following statements cannot be assumed from the diagram? So let's read each one and compare it to the picture. The first one says E, D, and C are collinear. Let's find them. E, D, and C. What's it mean to be collinear? They're on the same line. Is that true? Are they on the same line? Okay, so this one's fine. We're going to put a little check by it. It's good to go. That is a true statement. You could write the word true out to the side if you want. Next one. The intersection of line BD and line EC is D. Let's find them. BD goes through here. EC is right here. They cross at D. That is true as well. Next one. BD, line BD, is perpendicular to line EC. Why not? There's no right angle symbol, so this one cannot be assumed. This one is a false. You can't assume it. You cannot assume that one. What do you think I'm going to put on the next one? Line EC is perpendicular to plane G. Once again, no perpendicular symbol on the picture. It's no good. I'm going to write false. Go down and try checkpoints 3 and 4. I'll give you a little bit of time. On checkpoint number 3, it says, look at example 3. If the given information indicated that segment RX and segment XS are congruent, then how would the diagram change? So it's talking about this one up here. It says, how would this picture right here change? The only thing that would change is you'd have a congruent mark on RX and a congruent mark on XS. That's the only thing that would be different about the picture. To show they are congruent, you'd put congruent marks. So you either need to draw the picture or state it verbally. The verbal statement would be they would have congruent marks, congruent tick marks is what they're called, on RX and XX. On number 4. It says, in the diagram for example 4, this one up here, can you assume that line BD is the intersection of plane F and plane G? I told you a tip earlier on how to find the intersection of two planes. You look at the edges of the planes. Here's the edge of one plane and the edge of the other. Put a dot on the intersection. Do the same on the other side. The edge of the plane, there's the intersection. Trace it out. What line did I just trace on? Line BD. This is a true statement. Sorry, number 4 is a true statement. So once again, in the diagram, can you assume? Yes, we can assume that. We traced it out. We proved it. Good job.